Otoliths are fish ear bones, and the neat thing about an otolith is that it's a little like treasure trove of information. The center of the otolith is the birth of the fish, and as you go toward the edge of the otolith, that's the death of the fish. And it's like a tree ring. So if you look at a cross-section of a tree, you can age the tree. You can tell how much it's growing by looking at the distances between the bands on the tree. And you can even go in and look at the chemical composition of the cells in those bands. You can do the exact same thing with an otolith. So all of that information is contained inside that little ear bone. I've taken 10 fish from each of the locations that I've gone to, and I'm going to be analyzing those ear bones for aging the fish and also looking at the chemical composition, and then match it up to the chemical composition of the water at different locations along the river, and you can actually back calculate where the fish has moved over the lifetime of the fish by matching up the chemistry in the otolith with the chemistry in the river.
And that can tell you about the habitat?
You can see the peaks in the chemistry as it goes from overwintering site, which is one chemical composition, to a spawning location, which has a different chemical composition, to a feeding location, which has then yet another chemical composition.
Little antics there?
Not only that, but you can track it over the lifetime of a fish. So if I was looking at a 15-year-old grayling, I might expect to see not too much variation in the chemistry up until maybe spawning age. Then when the fish reaches spawning age, I would expect to see changes from the overwintering location to a spawning location and then back to an overwintering location throughout the rest of its lifespan. The chemistry is really dictated by the underlying glacial geology of the area. And the North Slope has a very nice, strong signal in its water chemistry because it was glaciated 3 successive times. There was the Otolith I, Otolith II, and the Sagavanirktuk glaciations. And the first glaciation extended far north and then receded. And then the next glaciation wasn't quite as far and receded, and the final one was even less far north and receded. So those are 3 different levels of exposure that the rocks have had. Over time, minerals leach out, the isotopes change over time while those rocks are exposed. So you get these differences. It's a gradient in chemistry from the headwaters down toward the Arctic Ocean. And that gradient is what allows you to use the otolith microchemistry as a signal. If there's no gradient in your water chemistry, then you really can't use otoliths this way. We're really fortunate that we have this great signal in our system.